Okay, chapter 4, classroom discussion. Let's solve some problems. First problem, we got a person who has a chance to survive a crash if uh, acceleration does not exceed 30 Gs. 1 G is 9.8, so 30 times G would be 30 times 9.8. And you calculate the force on a 65 kilogram person. And what's the distance traveled if it was brought to rest from 95 kilometers per hour? So your regular dynamics problem for car accident, reasonable numbers. 95 kilometers per hour would be like 60 miles per hour. So your highway speeds and 65 kilograms would be like 140 pounds person. So totally reasonable as well. Let's do the calculations, shall we? First of all, no kilometers per hour, you have to convert to System International, so meters per second, only System International units. That's the conversion. Kilometers disappear. Kilo means 1,000, so it's 1,000 meters in 1 kilometer. Kilometers cancel, and you're left with meters. Now hours cancel. Hours go on top, so hours cancel. Seconds go to the bottom, so it's meters per second. That's what we are left with. That's exactly the units for System International. So your 95 is multiplied by 1,000 and divided by 3,600. That's the conversion. Now this is the sketch. You got the initial velocity of 26 meters per second. We are slowing down. That means acceleration must be in the opposite direction. And the second Newton's law says F equals ma. So whatever the direction for acceleration, that's the direction for the net external force. So if acceleration is to the left, then the force is also to the left. So force, acceleration, initial velocity, and we come to stop, so final velocity is 0. And the question is, how far do you travel through? What's the distance traveled? What is the displacement? And calculating the force. So calculating the force is easy. You got 65 kilograms, an acceleration of 30 Gs, 30, and G is 9.8. So overall force is 1.9, so 19,000 newtons. That's the force that acts on you if you are in that car accident and trying to survive. Direction of the force is the same as the direction of acceleration because F equals ma. Mass is just a positive number, and vector acceleration, vector force, two vectors have the same direction. So we stop completely. That means final velocity is 0. And acceleration is constant. So we can totally use our kinematics equation for velocity with respect to x-axis. We stop, so my final velocity is 0. Initial velocity is 2639. That's what we figured out from the conversion from 95 kilometers per hour. And acceleration is 30 Gs. And it's negative. Why is it negative? Because acceleration is to the left. My positive x to the right, and acceleration is in the opposite direction. So this plus a vector means minus a as a number times the time total for that travel. You can solve for time. See, the time is less than a fraction of a second. That's what's going on in a car accident, once you hit the car from the opposite direction or a wall, everything happens really fast. You don't have much time to to react. And how much of a distance is traveled? Well, we don't know the distance, but we start from 0. Our initial velocity is positive 26. That's the initial velocity vector, positive 26 meters per second. Time is now known. We just figured out the time. Time is this much. And I keep more sig figs because it's intermediate calculations. And acceleration is minus 30 g's times the time squared over 2. So distance traveled is only 1.2 meters, like 4 feet, something like that. So everything happens very fast, and distance traveled is not much. And forces are 20,000 newtons or so. Oh, and that was the end of the problem. So what's the moral here? The moral is it looks like you're calculating dynamics because you're doing forces. But then once the question is for what's the distance traveled, how fast, what's the velocity, that's kinematics. So all you do is you figure out the force or the acceleration, and that is enough to solve kinematics. Usually it is enough to apply the other given parameters and solve for what's missing in terms of kinematics. So all the steps are shown. We did this before, so nothing new for constant acceleration equations. Just be careful with acceleration being negative this time because we are slowing down. So acceleration is in the opposite direction and its component on x-axis is negative. Same for force. For force, you have to show direction. Direction is same as acceleration because the second Newton's law says so. Okay, now we got an elevator with maximum acceleration is given. What's the minimum and maximum forces that we exert on the supporting cable? The key word is cable. What kind of a force for cable? Tension. So tension is always along the cable. So cable, cord, or rope, every time you see those three words, you got to consider tension. And that's exactly what you see on my sketch. So this is my elevator. And it's under tension, cable pulling it up, gravity pulling it down, and maximum tension or minimum tension, that depends on the acceleration. How do we get maximum tension? We get maximum when acceleration is up and your F equals ma. Yeah, you can see this fancy symbol. It's the symbol that represents the sum. So I don't like to say net. I like to put this sum symbol. So it's the sum of all the forces acting on the system, external forces acting on the system. That's mass times acceleration. Tension is up, so it's positive. Gravity is down, so it's negative. And if acceleration is upward, then you have a positive acceleration on the right side. Do the math. You can see that tension is indeed the maximum because you're going to get regular mg, the weight, and extra ma. So overweight, if you wish. And you get 51,000 newtons as the result. So maximum is 51,000. Now, how do you get the minimum tension? Well, minimum tension is when elevator is accelerating downward every time you press that button and door close, you probably feel that overweight if you're going upward, or underweight if you're going downward the very first second. You're like, oh, that's a little heavier. Like, oh, it's a little later. And your knees can feel that overweight or underweight conditions for the first moment. So that's the moment when you get either the minimum or the maximum tension. So acceleration is downward and onto y-axis, which is upward. Your acceleration is now negative. So positive tension, negative gravity, and now negative acceleration. Do the mathematics, do the calculations, you end up with 44,000 newtons, which makes sense. If maximum is 51,000, minimum is 44,000 newtons. That makes sense. That's what your regular elevator would provide. So as a engineer of elevators, you definitely want to do those calculations. So once again, draw a good sketch, show all forces, show the acceleration, show the F equals ma, represent all the forces, then do the components onto certain axis, so maybe both x and y axis. Keep in mind if it can be plus or a minus, and then just solve for what's missing. This is your approach. And there's no second part here, but if the question is how fast will the elevator go after, say, 5 seconds, then it's a sure sign you're going to do kinematics with all the parameters now given, acceleration figured out, and you can use the two equations from kinematics for constant acceleration. Okay, we got a window washer pulling her upward with bucket pulley apparatus. Slowly at constant speed. First of all, constant speed. Right away, you say what? Constant, no change. That means acceleration is 0. And if she increases the force, what would be the acceleration? Well, clearly not 0 anymore. And part B would be with accelerations. Part A has no acceleration. Part B has some kind of an acceleration. So here is the diagram with forces. You can see that there is tension in this cable, in this rope or cord. But the washer is pulling her on the other side as well. So you have another tension in the opposite cord as well. So the bucket washer combination has double force, which is a very rare occasion. But for this problem, if you have this kind of a system, that's what you have to consider. Both cords are within the system because you pull on one and the other one propels you upward as well. And then there's gravity downward, so double tension upward, single gravity downward. And what do we say for acceleration? If it's constant speed, that means 0 acceleration. Acceleration is just 0. So your F equals ma equation becomes half of gravity for tension. Do the mathematics with numbers given. Mass was 72 kilograms. It says mass of the person plus the bucket is 72 kilograms. So plug in the mass and then the G, 9.8. And get 350 newtons. That's a reasonable pull from a regular person. For your comparison cases, I can give you one number to keep in mind. I'm not sure if you remember, but there was a super duper heavyweight champion for boxing. His name was Mike Tyson, Iron Mike Tyson. And he could really knock out a person with just one good hook. And that was approximately 10,000 newtons. Okay, that force of that shot, a knockout hook would be 10,000 newtons. So every time you do some kind of a calculations and you're getting thousands of newtons, you should really ask yourself a question. Are we talking about Mike Tyson here? Because only Mike Tyson, or like a super duper heavyweight champion, could have provided thousands of newtons of, push or a pull. So chances are you made a mistake. So a person like a lady shown here, that hundreds of newtons, that's a reasonable pull, but not thousands. On the other hand, if it's some kind of a machinery equipment, like heavy industry, whatever, then yeah, you can get millions of newtons, but it's a different story. For your lab reports, when it's just a small cord connecting to small blocks, you can't get any thousands or even hundreds. It's going to be just, I don't know, 10 newtons, 20 at most, something like that. If that force is increased by 15%, then it's still the same physics. See, the physics is the same. And the only difference that you do have acceleration now because it's not constant speed anymore. And you have to solve for acceleration, which comes out to be 1.5 meters per second per second. How do you, what do you say for this number? Is that something reasonable? Well, the only other acceleration you can think of is free fall, and free fall is 9.8. So are we doing free fall here? No, we're doing something less intense. So acceleration-wise, acceleration is upward, by the way, same as the net force. You do have gravity downward, but tension wins because you eventually the lady propels it herself upward. So acceleration has the same direction as the net force, increasing upward. And 1.5 is less than 9.8, so that's reasonable. That's, not out of this world. So totally reasonable answers. Physics, once again, is the same. Second Newton's law, define the forces that enter the system, work out the acceleration. Is it positive, negative? Is it zero? And solve, as usual, with components. Components can be positive and negative. Be careful. If components have the same direction as your choice of positive axis direction, then it's positive. If force is opposite to that direction, then the force is negative component. Okay. Okay, now friction. So we got a truck and the crate on top. And then there is static friction between the crate and the truck. And the coefficient of friction is given. See, no units. Remember that Greek mu. Mu is the coefficient of friction and no units. So what's the maximum rate that we can decelerate and still avoid any motion of the crate? Well, that's a reasonable question because if you slam on brakes, that crate will hit your cabin, the driver's cabin, and it's going to be troublesome. You don't want that crate to move at any moment of time. So you have to be careful with accelerating or decelerating. But first, here comes a sketch which has a lot of information. And sketch is half credit. So let's focus on what we have here. So we got a crate on the truck, and there is static friction. First of all, there is gravity. See the gravity pulling on the crate downward towards the center of the earth. So gravity should be no problem. Then there is reaction from the flatbed. It's the horizontal surface, and there is a normal reaction force. Normal forces means perpendicular. It's perpendicular to the surface. So here's the surface, and normal force is perpendicular to it. And it prevents you from falling. So it's the other way from gravity. So up and down forces should be clear. Now, we have to show direction of motion. The best way to show direction of motion is to specify velocity vector, because the direction of velocity shows direction of motion. Remember, velocity is displacement with respect to time. And if displacement is positive, then velocity is positive. So that's one way. If displacement is negative, velocity is negative, so you're going the other way. So velocity vector shows direction of motion. Let's choose motion to the right. And then we are decelerating. We are slowing down. You have to slow down in a way that the crate does not hit the cab of the truck. So which way is acceleration? Well, if we're decelerating, if we're speeding, if we were slowing down, then acceleration should be opposite to velocity vector. And I mean, that's one way to see that acceleration is to the left. The other thing is to analyze the friction. You got to understand that the only force that prevents the crate from hitting the cab is the static friction. Static friction is opposite to direction of attempted slide. Which way is the attempted slide? Well, if that crate is to move, it will hit the cabin, and cabin is right here. So potential motion would be to the right. That's why the friction force is opposite. It's always opposite to the direction of attempted slide, so it is to the left. And if you'll calculate the net force, what are you going to get? One force is up. It counterbalances the gravity, which is down. So up and down gives you overall zero. But friction is never compensated. That's the force that stays no matter what. And this becomes the net external force acting on the whole system. And this force defines the definition, the direction for acceleration. Friction is to the left, therefore acceleration has the same direction. Newton's second law says so. Newton's second law says what? If you have a certain force, net force, then the direction for acceleration must be the same, because mass is just a positive number that you multiply by, and nothing changes in terms of direction. Friction is to the left, acceleration is to the left as well, because of the second Newton's law. So this is the analysis of sketch. By all means, we want to keep it static. We don't want kinetic friction, because if it's kinetic, it's already sliding and it's not good. So maximum deceleration is desired. So maximum means it's not less than, it's got to be equal to, because less, well, it's not going to be maximum. So equal option is on the table for this problem. Once again, for static friction, you have options. It's not necessarily mu times n, it can be less than that. But for maximum values, you do want the maximum possible normal reaction force that will define maximum static friction force. Okay, dynamics, second Newton's law. All the forces are shown. You got gravity, you got static friction, and you got normal reaction. Acceleration on the other side. And you say no acceleration in the y direction. because acceleration is perpendicular onto y-axis. So onto y-axis, you got positive normal force, same direction. You got zero static friction because it's perpendicular onto y-axis. You got negative gravity onto y-axis because it's pointing in the opposite direction. And acceleration is also perpendicular to y-axis, so its component is 0. What do you get? You get normal force equals mg. That's exactly what you expect. It's not going to fly up into the sky. It's not going to go towards the center of the Earth. So the vertical motion, no change. You have two forces balancing each other and no flying up or free fall downward. Makes sense, right? Now onto x-axis, you have perpendicular normal force. And if it's perpendicular onto x, it's just 0. You have static friction, which is opposite to positive direction. So it's a negative static friction. And then you have gravity, which is also perpendicular onto x-axis. If it's perpendicular, component is 0. So normal is 0, perpendicular. Gravity is 0 because it's perpendicular. Static friction is negative because it's opposite to the positive direction. What do you say for acceleration? See how vector shows everything right away? Vector is to the left, positive direction is to the right, so the component is negative. Solve for friction force. Friction is mu times n, mu times Fn. Negative and negative, you can multiply both sides by -1. Replace the normal force with mg because we just figured out that y-axis showed us that normal force is exactly the same as gravity. It's not always the case, but in this problem, we got this solution. So instead of normal force, you say gravity. And solve for acceleration. Fun fact, mass cancels out. It doesn't matter how heavy the crate is, acceleration is going to be the same. This is what proves our particle model approach. It's totally fine to say it's just a particle because mass cancels and mass does not enter the solution of the equation, the problem. Your acceleration depends only on the coefficient of static friction. Yeah, and the g, of course, but g is just a constant, so the key parameter is the coefficient of static friction. Now, I want you to, yeah, here we go. So this is the slide that you really want to keep in mind for the rest of your life. Tell it to your friends and relatives. Mass is not important. And only thing that matters is the coefficient of friction between the crate and the flatbed truck. So you should never ever buy used tires. For your car slowing down, all that matters is the coefficient of friction. And if you're wearing used tires that are not good, used tires don't have a good coefficient of friction. So if they don't have a good coefficient of friction, that acceleration is going to be more. I mean, it will take more time for you to slow down. And if there is a Lamborghini in front of you, you're going to hit that Lamborghini and it's going to cost you an arm and a leg to fix that car after the accident. So once again, It's not about the mass, it's only the coefficient of friction between the tires of your vehicle and the surface of the freeway. So first thing, do not buy used tires. Get the new ones that have the best possible coefficient of friction, and it might save you life, and you will not get into an accident. And then on the other side of that coefficient of friction is the surface. So for the surface, you have to remember that it's not always a perfect conditions for driving, and it might be raining or snowing. Well, not snowing in California, but if it's raining, friction coefficient drops 5 times. That means it will take you much more distance to slow down. And if there's an expensive car in front of you, you're going to hit that car and you'll get in trouble financially. You'll get in trouble anyways because it's going to be a car accident. Make sure you always slow down on the freeway if it's raining. If it's raining, you have to slow down. You cannot be driving 80 miles per hour if the limit is 60, 65 and it's raining. It's the worst decision you'll ever make in life because just a slight, you know, slight, like just a little bit of water beneath your tires and you really can't slow down efficiently. You have to slow down and pay attention and give it an extra distance between your car and the car in front of you. And if you see that someone is tailgating you and it's raining, just let that person pass and don't let them tailgate you because that person will hit your car right away if there is like a little bit of an emergency. There will be no enough time for that person to slow down. So never ever buy used tires. I know it's going to be much less, saves money. That's not worth the savings. And if it's raining and snowing, slow down. Do not drive over the limit. Like the limit is posted for dry, good conditions. And if you're driving over the limit, that's very stupid. Raining and snowing, you have to be like 10 miles below the limit. That would be a safe thing to do. Why is it so? That's why. It's all about the coefficient of friction only. No other parameters. Mass doesn't matter. Geometry doesn't matter. If you're driving a Porsche, doesn't matter. If you're driving a super duper sports car, you say, oh, I got a good tires, whatever. Okay, good tires. Friction is 5 times less during raining. It will take you triple the distance to slow down from the same speed, even if it's a Porsche with good tires. Okay, hopefully you've heard me and tell it to your friends and family. Okay, so here we go. Police, scene of an accident, 2 cars. The skid marks are 72 meters long. Coefficient of friction is given. What was the initial speed of the car that hit the other car? This is once again, the case that you would bring to the court, and the court would say, oh, you're guilty or you're not guilty. If you were driving within the limit, not guilty. If you're driving over the limit, you're guilty. You'll pay an arm and a leg for your insurance. You'll pay for lawyers. You'll pay for the court. And this is the problem that is going to be your life-changing problem, and you got to know the physics behind. So here's the car going to the right. That's the initial velocity vector showing direction of motion. And we are slowing down. We're doing skid marks. We lock the brakes. So acceleration is opposite because we're slowing down. Normal force is up, perpendicular to the surface. Gravity is down because Earth pulls us down. And what do you say for friction? Friction is opposite to the direction of motion. Therefore, if motion is to the right, friction is opposite, and normal force counterbalances the gravity. So those two forces give you zero net force. It is the kinetic friction, once again, that is the net force. And whatever the direction for the net force, that's the direction for acceleration. So all the vectors are shown. Final velocity is zero. And if acceleration is constant, we're going to use the kinematics equation. Final velocity is zero. Initial velocity is positive because it's pointing in the same direction as positive x. Acceleration is pointing in the opposite direction, so acceleration is negative. Now distance traveled. How much of a distance traveled? It's given, 72 meters skid marks. So my position is 72, starting with zero position. Initial velocity is positive, time is time, and acceleration is, once again, it's negative because acceleration is opposite to the direction of motion. We're slowing down, acceleration is negative, has negative component onto x-axis. T squared over 2. Two equations, three unknowns, so we need more equations. What kind of an equation? Second, Newton's law. Sum of all the forces equals to ma, or you say net force equals to ma. It's up to you which one you want to choose. What kind of forces are we talking about? Three forces: normal force, kinetic friction, and gravity. Normal force, kinetic friction, and gravity. Those are the forces. And acceleration. Well, for y-axis, no acceleration. If acceleration is perpendicular to y, no acceleration for y-axis. So for y-axis, positive normal, zero static friction, kinetic friction, excuse me, and negative gravity, and acceleration is zero. Once again, positive normal, negative gravity, zero kinetic friction because it's perpendicular onto y-axis, and acceleration is also zero because it's perpendicular onto y-axis. Do the math, do the algebra. Normal reaction force is the same as gravity. Boom, same as before. We expected that. Onto the x-axis, what do we have? We have normal force perpendicular onto x-axis, so it's zero. We have gravity perpendicular onto x-axis, it's zero. We have kinetic friction opposite to the direction of positive x, so it's negative kinetic friction. And acceleration is also negative because it's pointing in the opposite direction. So kinetic friction, negative, acceleration is negative, and the rest is just zero. That's what we have. And acceleration is negative. What is kinetic friction? Kinetic friction is the coefficient of kinetic friction times the normal force. And we now know that normal force is the same as gravity. Normal force is the same as gravity. So we substitute normal force with mg, multiply both sides by -1 to get rid of the negative sign. And once again, fun fact, mass cancels on both sides, and we have acceleration that is mu g. We did that before, same equation again. Yeah, it's not the final answer, so no rounding here. Once again, it's only the coefficient of friction that defines the acceleration to slow down. And now we know the acceleration. We go back to kinematics. We do the substitutions for the missing quantities, and we can solve for everything. This time, we solve for the initial speed. So we need initial velocity, v sub 0. Here we go. You do the substitution with time, get rid of time, and you solve for v sub 0. Two equations, two unknowns, time and v sub 0. So enough to close the system and solve for the unknowns. This is my substitution. Get rid of time, substitute the time for the second equation, and get the final solution for the initial velocity. We get 34 meters per second. It is approximately 76 miles per hour. Well, that's close. If the limit was 70, 75 miles per hour, then it's not really your fault. But if the limit is 45 or 50, then you go to jail, you pay the fines, you get in trouble. So the moral of the story, you have to keep the skid marks till the cops come. Because a smart person who took physics will try to erase the skid marks. And instead of measuring 72 meters of skid marks, if there's just like, I don't know, 50, then the v sub 0 is going to be less, because see how 72 defines the v sub 0. You definitely want to preserve those skid marks and take pictures, and do not allow the other guy to erase them from the freeway. Otherwise, you'll be the responsible party. So those skid marks, the length of the skid marks really tells everything about your initial velocity, and everybody knows it. I mean, cops know that, judges know that. So no matter what you're going to say in court, if the skid marks are 72 meters, they know that you traveled pretty fast. And how do they know? That's just a set of kinematics and dynamics, basics in kinematics, and just a second Newton's law from dynamics. Pretty cool story, in my opinion. Really covers everything we learned so far. And once again, if you have only two equations with three unknowns, do not panic. It's just a sure sign you have to use dynamics in your calculations. Okay, we got a box released on an inclined plane. That's the probably the worst case scenario for dynamics, because it's gonna cause a lot of trigonometry. We got the constant acceleration, good news, and there is friction. And the question is, what's the coefficient of friction? It doesn't matter what's given, it doesn't matter what's missing. Chances are you have to do dynamics and kinematics as usual. So first of all, let's take a look at the sketch with all the vectors and see how those vectors are working on this sketch. So inclined plane, there's a block going downward, and it says specifically it accelerates down the incline. You don't have to guess the direction for acceleration. You just show it downward towards the bottom of the incline. So that's the direction for acceleration. For gravity, we know gravity is always towards the center of the Earth. That's the direction for gravity. Friction. Friction always opposite to the direction of motion. If motion is downhill, then friction is uphill. And normal force, once again, see how normal force is very tricky? Normal means perpendicular. Perpendicular to what? Perpendicular to the surface that it travels across. So if the surface is inclined, then the normal force is also inclined. It's not vertical. It is perpendicular to the surface. So once again, for your inclined plane, I suggest you always use the irregular XY coordinate system. Your X is along the incline and Y is along the normal force. This way you save yourself from extra trigonometry that we're about to hit. You can still do the XY as usual, but you're going to get more trigonometry to discuss with that. So, dynamics, second Newton's law, let's go. What are the forces? Normal force, friction, kinetic friction, and gravity. Let's take a look at the y-axis first. That's my y-axis. What do we see? We see normal force along that axis in the positive direction. So it is plus normal force. What do we see for kinetic friction? Kinetic friction is perpendicular to y-axis. Every time a vector is perpendicular to a certain axis, the component on that axis is 0. So kinetic friction onto y-axis is 0. Now gravity. Gravity is a pain behind. For gravity onto y-axis, first of all, that's the component I'm talking about. And you can see it's pointing downward. So it's definitely a negative. But see how gravity is at an angle, and this dashed line will not give you just gravity. There's got to be some kind of reference angle involved. And let's take a look at the trigonometry of the case. You can see it's negative gravity times the cosine of an angle that the incline has with the horizontal. Let's ask a question. Why is it a cosine? It's easy to understand why it's negative, because the component is pointing downward, opposite to upward, positive y. But why is it a cosine theta? Let's take a closer look and do some geometry. So this is the sketch. That's the force that we're looking at. And what's given is the angle theta, say, I don't know, 30 degrees. So this is 30 degrees. Now let's take a look at the right triangle that is formed by the incline, the force of gravity, and the horizontal direction. So theta between the incline plane and the horizontal, force of gravity, and the horizontal direction. Now we know that gravity would be perpendicular to the surface, so it's 90 degrees here. And then theta there, let's say this is 30, then what's the other angle? What's the remaining angle here? Well, if this is 30, then the other one should be 60, because the sum total for all angles is 180 degrees, and 90 plus 30 plus 60, that's what's going to give you 180. So this is 90 minus theta. If theta is 30, 90 minus theta, 90 minus 30 is 60. You get this angle as 90 minus theta. Now, the angle between the y-axis and the inclined plane is 90 degrees. So you have 90 here, 90 minus theta there. So what is the remaining here? The remaining is theta, because the whole thing is 180. This is half, this is 90. This was 60. So this has to be 30. So this 30, same as that 30. If this is theta, then this is theta. So the moral of the story is whatever is the incline angle, it's going to be this little angle as well. So between the force of gravity and the slanted y-axis, you have this as theta. So we are talking about a component, y-axis component, and you can see that this component is adjacent to theta. And if it's adjacent, the function is cosine. So it's negative because it's pointing downward, and the hypotenuse is mg, and the adjacent side is hypotenuse times the cosine of the angle, because it's the adjacent side. So your mg vector has a negative component, and it's not just mg by itself, it's also the cosine of theta that you have to keep in mind. And what do we say for acceleration? Acceleration is perpendicular onto y, and every time a vector is perpendicular, its component is 0. This is your y-axis to consider. Y-axis for the second Newton's law, main dynamics equation. Now the x-axis. What do we get? X-axis right here. Normal force is perpendicular onto x-axis, so its component onto x is 0. Kinetic friction. Kinetic friction is opposite to positive x, therefore it has a negative component onto x-axis. Acceleration. Acceleration has the same direction as x, positive direction, so acceleration is just plus ma. And once again, the same question for what's going on with gravity. Well, for gravity, you can see that it's now positive, and there is a sine function. Why do we have mg sine function? Let's take a look at the geometry again. So here we go. That's theta that is given. This is my x-axis. And now I'm taking a look at this right triangle that is formed by the same gravity, the component that I'm looking for, and the line that I'm going to build at 90 degrees perpendicular to the surface. And if this is theta, and this is 90, and this is 90, and this one is 90 minus theta, we already discussed it. It's 90 minus theta right there. It's 90 minus theta right there. So from this right triangle, you got 90. You get 90 minus theta. So what's this one? This one has got to be theta. And then if this is theta, then alternate interior angles. This is your transversal, and two lines are parallel. So angles are congruent. And the moral is, once again, if this is theta, then this is theta. If this is theta, then that is theta. And your component is now opposite to theta, and it's in the same direction as positive x, so it's positive. And as long as it's opposite, it's got to be the sine function that defines the component onto x-axis. So it's positive, and it's not just mg by itself. It's at an angle, and it's the sine of that angle that we're talking about now. So mg sine theta, that's the part of the dynamics equation onto x-axis. So two equations, solve for anything. See how physics pretty much stops right there. On the test, if you show me a good sketch with all the forces and those two equations for components, if there are no mistakes with plus, minus, sine, cosine, or 0, I'll give you like 8 out of 10 just because physics is correct. The rest is really algebra, just substitution, elimination. If you can do algebra, good. If you can't, it's really not my job to teach you that. I'm still showing my work here, and you get the final answer, and don't forget sig figs and units. But it's really up to you how you're going to solve the system of 2 by 2 two equations with two unknowns. This time we want to solve for the coefficient of friction. Make sure no units. This time it's the very rare case when there are no units because it's coefficient of friction. And practice with your calculators. See, you have an expression, grab a calculator, make sure you get the same answer. Because sometimes the formula is correct, numbers are correct, but then the final answer is incorrect because you can't use your calculator properly. You can't do the input. I suggest you always do it step by step. Do not input everything at once. Do this times this first, the whole thing times cosine 27 second, and then do this over the previous value. So three distinct operations, and chances are you'll minimize your mistakes. Oh, good news. That was the end for chapter 4 discussion. Let me pause the recording.